what we did here. We took this and we did a line going up and down. We call this the y-axis, or the y-symmetry line, and this is the x-axis. You see, we just drew a little chart here. And this little chart tells me that what's on the right is different from what's on the left. And that means it's a polar molecule. And it consists of a one polar bond. You see the polar bond between chlorine and carbon? Here it is. Chlorine and carbon, 0.5. And it consists of 3 non-polar bonds between carbon and hydrogen, which is here. Now, why am I emphasizing this? In the experiment we're going to run today, you're going to see, we're going to construct a couple of different molecules. So let's say, I'll give you an idea of one molecule. We're going to make what appears to be a fairly complicated molecule. One, two, three, four, five, 6 atoms. You see the 6 atoms? Right? In this, we're going to ask, and in the experiment itself is a table, and the table asks you to list the polar bonds that are existing in that molecule. The polar bonds, and I'm looking at now page yeah, that's the one. I'm looking at page 6.4. It's this page here. Only about this way, it's more than 6.4. The first row across is ammonia, you see NH4. The molecule under it is CH4O. And you see it's CH4O. That's the way we're going to assemble it. We're going to assemble the model that way. If you go across, it says, what's the electron dot formula? After you assemble the model, you'll draw the electron dot formula. You will then draw the Lewis structure. The difference between a Lewis structure and an electron dot formula is Lewis structure removes the bonding electrons and turns them into lines. Okay? That is a Lewis structure, but it's not complete. A Lewis structure would have 2 dots in it. This would be the electron dot formula. So the difference between an electron dot formula, that's an electron dot formula. And how do you draw that? Remember, we had rules for doing that. We'll go through the rules again. This is an electron dot formula. A Lewis structure takes the bonding electrons, which are all of these electrons, and turns them into straight lines, connections. This one is, right? It doesn't touch the non-bonding. The non-bonding electrons stay. All right? So this now becomes a Lewis structure. The next column, what's the next column over after it says draw the Lewis structure? It then says something about geometry. What is the bond? What is the bond angle? I'm not going to worry too much about the bond angle. What I'm worried about is the geometry. There are a limited number of geometries. And geometry has to do with a center atom. This is called the center. And it has one on one side and one on the other. Right? A center atom and 2 things. Where is the center atom here? Both. There's 2 center atoms. You see? There's this one here. So, with respect to the carbon, you should be able to describe the geometry. With respect to the oxygen, there's a different geometry. This one here has this carbon, and you have to focus only on the carbon, meaning get rid of this for a moment. What is the carbon connected to? 4 items. Therefore, relative to the carbon, it's tetrahedral. All right, so this would be tetrahedral. Now we want to look at the other one, and we'll say relative to the oxygen, oxygen has how many things attached to it? What does oxygen have attached to it? 2 things. It only has carbon and hydrogen. Relative to that, this is called a bent structure. All right. Why is it bent? Because it has 1, 2, 3, 4 electron groups. The 4 electron groups are tetrahedral. When you remove the electrons, you're left with a bent structure. Here's the Here's the electron structure around that oxygen. Here's the oxygen. I have 2 electrons up and 2 electrons down. You all know this is a tripod, right, guys? I did this in the last one, right? This is the 2 electrons coming out in your face. These 2 are going back into the blackboard. And this one here is sticking straight up in the air. This pair is sticking straight up in the air. So these 2 electrons are, one is forward and one is up. So they're already bent. And these two hydrogens are facing backwards. So this would be a hydrogen over here. And this is a carbon, I'm sorry, not hydrogen. Hydrogen and carbon, yes. So this is bent relative to the oxygen, but it's tetrahedral relative to the carbon. Now this sounds confusing as you go through these with many, many models. You practice this and you'll get good at it. You say, oh, piece of cake, not a problem. I understand what this is all about.